Cek, 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 satu dua, cek, cek, cek. Oke, hah? Cek, Bang Edwin. Bang Edwinnya? Oke. Assalamualaikum warahmatullahi wabarakatuh. Good morning, ladies and gentlemen. A very warm greeting to every one of you. First, I would like to thank for the Honorable Dean of Forestry Faculty Tanjung Pura University, Dr. Insinyur Farah Dibah SUT MSI IPU, the Honorable Lecturer of Forestry Faculty Tanjung Pura University who joined us in today's seminar, and welcoming our special guest today from California University, Professor Fernand Lewis, PhD, and lovely audience in today's seminar Ramin series 32 about urban entomology. Hereby, I'm the master of ceremony for this seminar. Let me introduce myself. My name is Nurul Hamzah. So to shorten our time, let us start the first session by singing the Indonesian national anthem and March Rimbawan. For this session, we kindly appealing the audience to stand up. and gentlemen, please have your seat. Next, a prayer session. The prayer will be led by Mr. Edwin.
Assalamualaikum warahmatullahi wabarakatuh. Sebelum memulai acara, alangkah baiknya kita berdoa, dan bagi yang beragama Islam, izinkanlah saya memimpinnya. A'udzubillahi minasyaitonirrajim. Bismillahirrahmanirrahim. Ya Allah, Tuhan yang Maha Kuasa, pada hari ini kami berkumpul dalam kegiatan Ramin Series 31 Urban Entomology dengan hati yang penuh syukur atas segala nikmat dan karunia-Mu. Kami memohon kepadamu agar Engkau senantiasa memberikan bimbingan dan petunjuk-Mu dalam setiap langkah yang kami ambil hari ini. Ya Allah, dan berkahilah kami pada kami ini, para peserta, para pembimbing, dan seluruh tim yang terlibat dalam kegiatan ini. Jadikanlah acara ini sebagai sarana untuk meningkatkan kemampuan pengetahuan dan keterampilan kami, sehingga kami dapat memberikan kontribusi terbaik dalam kegiatan ini. Ya Allah, bukakanlah hati dan pikiran kami untuk menerima setiap pelajaran dan pengalaman yang berharga selama kegiatan ini. Jadikanlah kami hamba-hamba-Mu yang selalu bersemangat dalam belajar dan bekerja, serta mampu menghadapi setiap tantangan dengan penuh kesabaran dan kebijaksanaan. Ya Allah, jadikanlah kegiatan ini sebagai jalan untuk mempererat tali silaturahmi di antara kami, memperkokoh kebersamaan, serta meningkatkan semangat kerja sama dalam mencapai tujuan bersama. Ya Allah, jauhkanlah kami dari segala rintangan dan hambatan yang dapat mengganggu kelancaran acara ini. Berilah kami kekuatan dan keikhlasan dalam menjalani setiap proses dan tanggung jawab yang kami emban. Ya Allah, ampunilah segala dosa dan kesalahan kami, baik yang disengaja maupun yang tidak disengaja. Jadikanlah usaha dan ikhtiar kami dalam kegiatan ini sebagai amal ibadah yang Engkau terima. Dengan segala kerendahan hati, kami mohon kepadamu, ya Allah, kabulkanlah doa dan harapan kami, berkahilah acara ini dari awal hingga akhir, dan jadikanlah hasil bermanfaat bagi kami semua. Amin, amin ya rabbal alamin. Allahumma inna nas'aluka salamatan fid din, wa afiatan fil jasad, wa jadatan fil ilmi, wa barakatan fil rizki, wa tafadan qoblal maut, wa rahmatan indal maut, wa mafiratan ba'dal maut. Allahumma hawin alaina fi sakaratil maut, wa najatan minan nari afwal hindal hisab. Rabbana la tuzigh qulubana ba'da hidaytana wa hab lana min ladunka rahmah innaka antal wahhab. Rabbana zalamna anfusana wa illam taghfir lana wa tarhamna lanakunanna minal khasirin. Rabbana atina fid dunya hasanah wa bil akhirati hasanah wa qina azabannar. Subhana rabbikal izzati amma yasifun wa salamun ala mursalin walhamdulillahi rabbil alamin. Assalamualaikum warahmatullahi wabarakatuh.
Furthermore, is a speech by the Dean of Forestry Faculty to Dr. Insinyur Faradiba Ashwood, MSc IPU. Please, time is yours.
Assalamualaikum warahmatullahi wabarakatuh. Selamat pagi semuanya. Salam rimba. Good morning, Mr. Professor Fernand Lewis from University of California and his beautiful wife, Ibu Lisa. Thank you for coming to our campus, Forestry Faculty, Tanjung Pura University, and this is special day that you will give a lecture about the urban entomology. Ya. Yang kami hormati Bapak dan Ibu dosen yang hadir pada acara Ramin Series 31 pada hari ini. Ada Ibu Profesor Dr. Yuliati Indrayani, kemudian Ibu Ratna Herawati Ningsih MSI, Ibu Yeni Mariani PhD, kemudian Bapak Muhammad Dirhamsah MP, Ibu Gusti Eva Tavita MSI, dan Ibu Munadian MAGR. Kemudian ada yang di belakang, nggak kelihatan ya. Jadi Bapak Ibu dosen yang hadir pada hari ini, kemudian Bapak Uray Hermansah SH, koordinator dari akademik, subkoordinator akademik, serta semua panitia yang hari ini telah mempersiapkan setelah liburan ke Kucing ya. Dan langsung hari ini ada kegiatan dua. Dan ini merupakan rangkaian juga kita kedatangan tamu dari University of California, Amerika Serikat, Bapak Profesor Fernand Lewis. Beliau adalah ahli tentang entomologi. Entomologi itu kalau dipelajarinya adalah ilmu tentang serangga. Jadi nanti akan disampaikan tentang urban entomologi, khususnya juga rayap. Tidak hanya rayap ya, kalau di urban, di perumahan tuh kadang yang paling menyebalkan itu kecoa misalnya ya. Jadi ada kecoa, ada tikus, ada rayap. Nanti semuanya akan disampaikan. Semoga bisa menambah ya, karena ini tamunya dari jauh nih, dari Amerika datang. Jadi Ibu harapkan mahasiswa semuanya aktif, kemudian juga bertanya atas tadi materi yang akan disampaikan. This is our student from the second year student. Then they will listen to your talk about the urban entomology, and I ask them to give a questionnaire, or maybe if they don't have questions, so you have to give a question to them. Ya, oke. Baik, dengan mengucapkan Bismillahirrahmanirrahim, kami membuka acara Ramin Series ke-31 pada hari ini. Semoga membawa keberkahan dan kemajuan bagi Fakultas Kehutanan Universitas Tanjung Pura. Billahi taufik wal hidayah. Assalamualaikum warahmatullahi wabarakatuh. Selamat pagi. Salam rimba.
Thank you, Dr. Engineer Faradi Baes with MSc IPU. Before we go to the next session, let us take a photo together. To the dean, also our speaker and the lecturer, please stand up in front of the stage. Also, Mrs. Lisa, you can join to take a photo. Dimohon cek. Dimohon kepada teman-teman yang duduk silahkan berdiri terlebih dahulu. Next session is the top of the session our seminar today, but it will be led by Mrs. Munadian Esut MAGR as a moderator. We also have Sri Suatu Saada as our translator today. So please to Mrs. Munadian, also Professor Luis, to get your seat. Yep.
Baik, Assalamualaikum warahmatullahi wabarakatuh. Good morning, everyone. I would like to thank you for coming to our today event. The Honorable, our Dean, Ibu Dr. Paladiba Esut MSI Ibu, and also Vice Dean. I cannot see them here, probably still teaching. And another lecturer, thank you for coming. And of course, my lovely student, thanks for come to this event. And the foremost one for our distinguished guest, Professor Fernand Lewis from California University, who is come far away, not only different country, but also different continent. So he fly away from America to Pontianak, I think more than 14-hour flight. Yes, more than 14 hours. And thank you so much for coming here. And of course for his beloved wife, Lisa.
Right there.
Thanks for accompanying him. Well, today we will listen and we will learn about urban entomologists from the top world entomologists from California University. You will give a presentation about urban entomologists for all the thing. Okay, sure. From Bernard Lewis is entomologist, top world entomologist, and he is the, I can say, best scientist in entomologist field. So please take this opportunity to learn many things from him and to gain many knowledge about urban entomologists. As a forester, maybe as a forestry scientist, for us, we are not, we quite familiar with entomologists, but for urban entomologists is not so familiar. So we learn many things from him today. Okay, for Bernard Lewis, time and place is yours. Please, you can walk.
Okay,
sure.
let me walk. Let me see. First of all, if you guys, can you hear me? It's okay? All right, good. It's best I walk out here because sometimes I move. Good morning. I am so pleased and honored to be here today. We've been here maybe going into the second week. Indonesia is a wonderful country. You should be proud of your country, your faculty. You have beautiful landscapes. And it's my first time here. I've been thoroughly impressed. Okay, to Do I have a? Ah, yes. Okay. So I have to explain my title, Urban Entomology. And I'll try and talk slow because some of you out there, your English is maybe not so good. Okay, that has to do with insects that occur in cities. Now, you're going to go, well, you guys are foresters, or you're in the forestry college. I should tell you, my academic title on the Berkeley campus as an urban entomologist, I also had a joint appointment with our forest products lab. Oh. Oh. I'm sorry. I'm sorry. Yeah. Okay. Wow. Okay. So I'll start again, but I'll make it quick. I also was with the Forest Products Lab in California at Berkeley. So in my training, I had to learn forest insect pests, bark beetles, spruce budworms, diseases. So it's in my training. So we're actually closer, very close. And remember, the homes that are built out of wood, weren't they first in the forest? So they're related, okay? All right. Let me see how I advance this. Maybe it's this way. No? How do I do it? Ah, it's okay. I'm okay. Sorry, my bad. So in my talk today, I will give you background on humans' need for food and resources. That's going to be important when we talk about urban. I will define what urban entomology means. I will give you some definitions on pest management. And then I will tell you the history of urban entomology, how it got started. And then I will mention the top 4 pests, urban pests in the world. Because the fastest growing habitat in the world right now are cities, right? Particularly here in Asia. You have many cities throughout Asia that have 10, 15, 20 million people. Where cities are being built faster than ag, than forest. That's just the way people are. Okay. So, for millions of years, humans have survived on Earth, right? Millions of years humans have been on Earth. So the question is, how? How did they do it? First of all, people gathered food. They gathered food. This is me at my house. These are mangoes. I grow mangoes. Yeah, I have a mango tree in California. And my mangoes are small, but they're very tasty. Very tasty. And so that's what humans first did. They gathered food where they could find it. As humans got fancier, they went fishing. This is me and Lisa were in the Amazon in Brazil. This is a piranha. You've heard of the piranha? We caught piranha and ate them. You can eat them. And then when people weren't gathering food or fishing, they were hunting. And this is me in the Amazon with a blowgun. I missed I'm a terrible shot. Bad. Not so good with a blowgun. So, but humans learned plants would grow. And they watched, right? They watched the plants grow. And over time, we learned to have agriculture. We grow our own food. Now, this is a shot from North America where we grow corn. You don't grow corn here, but different plants around the world. The world is highly variable. Wherever you go in the world, you can find some type of food or grow it. You just have to figure it out. And humans are very good at figuring it out. This is a shot from California. We can grow citrus. We can grow grapes, we can grow palm trees, all in the same picture. You know, so humans are very smart. Okay. More food means more people. If you look at the graph through time, see? We have 8 billion people in the world. The end of this century, we'll have 10 billion. Why? Because food. More food, more people. That's how Earth works. So where do all these people go? They go into cities. You recognize the cities, right? Yeah, so we have, here's Jakarta. There's London, that's Beijing. Rio de Janeiro, London. Lagos, Nigeria. People live in cities. Most of the people in the world today, over half the people in the world, over 4 billion people live in cities. They don't live in the ocean. They don't live on the mountaintop. They don't live in the desert. They live in big cities. I don't think that trend will change. Okay, so something followed people into cities, and we call it pests. Why do pests follow people? Because we bring our stuff, our food, our clothes, our hair, our babies, our wood. The pests follow us. That's just how Earth works. I have a book. We talk about pest problems around the world. Here's one. There are many books on the history of entomology. And if you look at books, this is a book from California that talks about the history of pests in cities. The Egyptians, the Babylonians, what else? Even people in the rainforest, they've always had pest problems. And this book lists many, many of them. And you have your own local history too. So I just want to stop and ask you as an audience, when I use the word pest, and how do you say pest in Indonesian? Hamra? Hama? Hama. So if I say hama, what do you think of? Name termite. What else? Some more. Beetle? Huh? Cockroach. Okay. All right. Mosquito. More. Flies. Ants. Any more unusual pests? Unusual. Bee? Okay. Now it's my turn. This is gonna, I'll hold it. Here we go. What's this? What do you think? Cookie? Mud? Any thoughts? In the back? Can you guys see it? What? A hive? That's why I'm gonna hold this, because when I tell you what it is, you're gonna be mad at me. What do you think? Termite? Not yet. She knows. This comes from India. This is cattle dung. Cattle dung. Okay. Now we have the professor sitting right here. In yellow, can you read in English and Indonesian for the audience? Oh, that's just in the yellow. Here.
We compass ini kotoran
Read for the audience.
dari sapi ya. Ya, itu tadi yang ditunjukkan adalah kotoran dari sapi. Diperoleh dari India.
You get it? You guys get it? This is a pest. Well, how did I say pest? Hama. Hama. How can this be a pest? It's not alive. It's dung from cattle. Let me explain. Cattle. Okay, cattle aren't so important in Indonesia. in North America, we have many, many cattle. They eat a lot of grass. They go to bathroom 12 times a day. 12 times a day times millions of cattle is a lot of dung on the ground, the grass. The grass does not grow through for years. So the cows can't eat. So this hama is a pest in California. So what do you do? If this is a pest, what do you do for control? You ever thought? Pesticide? No. You pick it up? No. We imported dung beetles from South Africa and Australia. Remember the dung beetles you see you have them here. They take the dung and roll it and bury it. That's what we did to control this pest. Now that they're looking at me, all kind of, here's my point. The word hama, it depends on people. God, Buddha, and Allah did not produce pests. It's people in our head. You need to understand that. You understand? If you control what's in people's head, you solve the problem. If you don't control what's in people's head, the problem's still. Do you get it? Okay. Let's move. Okay, because we have pests, we have agricultural and entomology. Okay, just in case, let's go. Entomology is a Latin word, and it just means segmented. It's another fancy word for insects. Entomologists use Latin. Why do we use Latin? Anyone know? Why Latin? Okay, so the person who named most life forms on Earth, the first person, well, officially, was Linnaeus. You heard of the man Linnaeus? He was Swedish. In the 1700s, he was the one that used Latin. So when we talk about termites, Captotermes formosanus, or Blata dramatica is for cockroaches, he started that in 1758. Why did he use Latin? Latin was considered a dead language. It's a universal language back hundreds of years ago. If you go back to the 1700s, all local cultures have names for their insects. Like, what's Indonesian for termite? What's Indonesian for cockroach? See, I don't know that. But if I say Captotermes formosanus, get it? We standardize, level the playing field. That's a good thing, right? It was Linnaeus who did that. Okay, so that's the entomology part. I have a book on Latin terms. I'm going to give that to you. You're going to need that for that beetle book. So those are your students. When you learn Latin for the trees have Latin names too. Pinus radiata, right? You have many Latin names for trees. If you don't know what that means, buy a book, look it up. You can see the meaning. There's meanings. You just have to look it up. So for agriculture, farming, that's agricultural entomology. You guys are in forestry. We have forest entomology. Bark beetles are very important, right? All over the world, bark beetles are important. We have medical entomology, mosquito. They bite people and livestock. So, but what happens with urban entomology? How do we define that? So I have to show you a couple things. Success. How do we measure success? So in agriculture, like your oil palms, it's called economic injury. So when the termites or beetles or disease are too bad, you lose production. That's bad. It's called economic. You can measure that. In medical entomology, you can measure that. People's health. People get sick, they die, they go to the hospital. What happens with urban entomology? It's called aesthetic injury. Now, that's a fancy word. Now, the professors will know. How do you define aesthetic? Right? That's different from economic. That's different from healthy people. How do you measure it? How do you define it? I will give you an example. I call it the yuck factor. So, and if you don't know the word yuck, let me show you a video here. I think this is a piece of pizza, and if you pull it open, that's aesthetic. Get it? Yuck. That's what makes urban entomology, those are soldier flies. They're a type of fly, maggot. So everyone looks at, So aesthetic value is hard to measure. You can measure oil date palm, oil production per hectare. You can measure sick people. How do you measure yuck? That's what makes urban entomology so difficult, because every one of us has a different yuck factor. I happen to like this, but okay. Got it? Okay. Now, urban entomology is a discipline. Where did it come from? This man right here, Walter Ebling. That's what he looked like. He's dead now. He lived to be 105. This is the first book called, he is the father of urban entomology. Oh, it says, here's the book. He's also a graduate from UC Berkeley, and Riverside. But he wrote this book, 50 years ago, in the early 70s, maybe 60 years ago. He defined urban entomology. He's a very famous guy, at least in Western cultures. I have to be mindful. Urban entomology, before it was defined, many cultures have fought bed bugs and termites and cockroaches for centuries. If you read the Chinese literature, they have been battling termites and bed bugs for centuries. But it was Walter Ebling who first put it in a book that we could all read. This book, it's very old, it's out of print, but you can get it on the internet for free. It's available. Just look for urban entomology. All right. So, I want to look deeper into, now urban entomology has to deal with cities and our homes. So let's look a little deeper. There's a book out there called, I have brought it here, Never Home Alone. All right, let me explain. So several years ago, professors at North Carolina State University, that's another university, they sent scientists around the world to look in homes to see what was in there. Entomologists. They sent like 5 or 6 to go look up and down, collect. I know many of you think your home doesn't have any insects, but do you know where to look? If you don't know where to look, you'd be surprised. So they looked. And this just shows you different parts of the book. This book shows, it's hard to see, but I think, whoops, let me come back. Oh, sorry, hold up. I pressed the wrong button. Okay, I think it's this one. Okay, the biggest habitat in the world, right? Okay, the Arctic and the Antarctic are big, and there's no people there anyway, so who cares? You know, the Antarctic does have pest problems. Do you know that? At the South Pole, they have pest problems. How can you have pest problems where it's minus 50 C most of the year? You ever wonder about that? How? Well, there's 2 things. They have people there in stations. They eat fresh fruit. They get fruit flies and scale. I've also told they have cockroaches and bed bugs, but that's another story. Also, you're right. Our poles attract seals and walruses and sea lions. And normally they have pests, ectoparasites. We were just in the Galapagos. The Galapagos are near the equator, but on the other side of the world. in the middle of the ocean, many seals. They also have horseflies, tabanids, that bite and suck blood. They suck the seals, and when they're done with the seals, they suck us. That's the way Earth works. So birds and seals have been attacked by insects long before humans, and particularly where they nest. Okay. So cities are our fastest growing environment. And that's because inside the building. I'll give you an example. This example comes from New York City. And maybe you haven't been to New York. It's a big city. There is more space inside the buildings than on the ground where the buildings sit. It's like 3 times more. So the fastest growing environment is indoor spaces for us, humans. It doesn't matter if it's Jakarta, it doesn't matter if it's Africa, that's just the way it works. Humans like to live in spaces. So I've talked to scientists who've gone around the world looking in homes, North America, Europe, Africa, Asia. They look real carefully. And what they find, the most common arthropod they find are actually book lice. Do you know what book lice are? Those little tiny insects that are in book lice. You find them on all continents. And other things. But they found many more. This is an example from one home. This is from North America. You go in the house, people say, I have no insects. And then they spend a couple hours looking, digging. That's a lot of insects. In fact, just in looking in 554 rooms in 50 homes, this was in North America, 10,000 specimens. 34 orders. There's only 35 orders of insects. Over 300 families. Okay, many of them were dead, but they were there. Here's a pie chart. So inside people's, in their bedrooms, in their bathrooms, they got the spiders, they got the flies, they got the millipedes, here's my termite, they got the carpenter. That's all over the world, doesn't matter. So you're going to say, let's pick on one. Sweden. You guys don't go to Sweden. Sweden's very cold. How do they have insects inside? We have heaters, and we like temperatures. What is it? 27 Celsius. What's 70? 13. Humans like 13 inside buildings. 13. Insects, fine. They're fine with that. So that's why places like Germany and Sweden and Iceland has insects inside the buildings. Iceland. And if you go outside, you guys don't have snow. No snow in Indonesia. You're lucky. Okay, now I want to go and talk about, the way it works. On Earth, we have at least 2 million described species of insects alone. 2 million, all over around the Earth. They say, and that's just by looking through microscopes. When we use DNA, you've heard of DNA, molecular. Has anyone done a genealogy test here? Maybe you have. Then you know. All right. So let me give you a human example. For humans, when you want to find out about your family, you ask your grandmother, maybe your grandfather. Grandma knows more. Or great-grandma. And then they tell you your family story. When you do the DNA tells a different story. Sometimes you're not related to or maybe you have many more relatives. That's what happened to me. I grew up, my grandmother told me I was the eldest of 10 children. 10. But after the DNA, I'm number 4 of 18. Okay. So we'll probably find more insects. So most of those insects are not a problem to humans. They're outside. That's good. So I'm going to pick 4 that are common in buildings around the world, including Indonesia. So let's pick on one. Let's see if you recognize this one. You recognize this insect? Well, there's another yuck factory here. Well, I'm in the way. Oh, other way. I'm in the way here. Do you recognize that insect? Yeah, cockroach. Ah, all right. So Linnaeus named cockroaches, back in the 1700s. He called them blatted. So if you look in the book, blatted, that's just a name for a roach. That's Latin. That's why they're in the order Blattaria, because Linnaeus, the way taxonomy works is normally you accept the first name, the oldest name. That's how it works, unless there's some problems. What is a cockroach? They're flat, dorsal-ventral, they flat, squish this way, long antennae, very fast, right? They may or may not have wings, very fast. In America, we call them cockroach. We take that from the Spanish name cucaracha. And I don't know, what's in Indonesia for cockroach? Katoa. See that? See, wherever I go in the world, you have a different name for a pest. And we're going to have some fun coming up on that real quick here. Indonesia does have species, different kinds of cockroaches. You're in the tropics, of course you do. At least 87 different. And you might wonder, where do I get these numbers from? There's a special website called iNaturalist. Have you ever heard of it? Okay. If you type iNaturalist, it gets you into a special website. And around the world, we have, our cell phones. We take pictures, click, 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 click. And they put them in iNaturalist around the world. And then there are experts there who will name them for you. So no matter where I go in the world, like I did for here, I went Indonesia, insects, and thousands of names pop up. It's called citizen science. Technology allows all of us to be a participant. It used to be, in the olden days, there's only the professors who knew everything, but now everybody knows more, the internet. And I think that's good. See, it's called iNaturalist. Anyone can, it's free. It doesn't cost you anything. So if you find a new insect, take a picture, put it in there. You can download it. It's cool. All right. Now, let's talk about some of these are the most important cockroach species in the world. I want to start with this one. In America, we call it the American cockroach. What do you call it here? Do you have it? Do you have a common name for it, though? No? Just Kachoa. Okay. Let me use this as a prop and I'll give it back to you. All right. I want to give you a little insight how science works or doesn't work. This name, American cockroach, that's a common name used in America and Western Europe. Where did it come from? Linnaeus in the 1700s in Sweden was the first to name this cockroach. Now, he named it in Latin. So you need a little Latin book. He named it Paraplaneta americanus. Okay, Paraplaneta is Latin. It means wanderer. Americana means it came from America. Because when the first samples that Linnaeus got, Linnaeus never traveled the world. It was his students, you guys. You went running around the world for Linnaeus. So his students brought back this cockroach to Sweden from the Americas. Now, when they did the DNA, when you look at the DNA in your cells, the origin for this cockroach was Africa. Oops. So with the wrong name. How did it get to the America? The Portuguese. Remember the Portuguese on ships? They spread it all over the world. Hundreds of years ago. I'll give you another one. This one's even more fun. I like this one. This one here, that's called the German cockroach, Blattella dramatica. See the chevrons, those stripes near the head? That makes this a German cockroach. That makes it a female. That's an egg case. How did it get its name, German cockroach? Linnaeus named it Blatta dramatica. Blatta is, again, Latin for cockroach. Dramatica, Sweden was fighting a war with the Germans. He didn't like them. He named a cockroach after him. So be careful with common names. Common names are are very misleading. If you know the term misleading, right? Okay. So what do we name good insects, right? Monarch butterfly. You've heard of monarch butterflies? It's that big orange one, but very pretty. Things that are pretty we name after kings and queens. Things that are pests we name after people we don't like. This one, I'll show you one more example. The oriental cockroach. Now that's a derogatory term. That's a term that'll probably change. It's very demeaning to name that oriental cockroach. It implies bad things from things that can happen in the Orient or Asia. The problem is the DNA says this is from Africa anyway. So it's all wrong. So the Latin name for it is lateralis is the Latin name. So all the names for insects are starting to be changed. I personally think, this is my opinion, we should name insects like we name planets. Now, when the professors here were young, we had planets, Mercury, Jupiter, Pluto. And then we had telescopes, and there was a lot more stuff out there. So now they use numbers, right? So when we find galaxies and new planets, we give it a number. Number is more neutral. It's not disrespectful. So it's going to happen. Maybe not in my lifetime, it'll happen. I want to mention one other thing about naming things. Those of you who have gray hair like me, remember when Pluto was a planet? Pluto used to be a planet, and they took it away. They said it's a rock. Okay, let's go. A little bit on what do we do to control cockroaches? Because people don't like cockroaches. So you spray, right? Other things that have been tried, we spray liquids, dust, gels, baits. You probably heard of that. Parasitic wasps. This is a parasitic wasp to control cockroaches. I don't think you've used that yet here. Parasitic fungi, parasitic nematodes, heat. If you heat the building up, you can kill them. Carbon dioxide, moving air. That's work in California. If you have where's that come from? We have sewers below our streets. You have sewers too. Many, many cockroaches in there. Used to be you put pesticide in the sewer, but that's not good because it goes in the water and hurts the environment. They found that if you put big fans, moving air helps to keep the cockroach numbers down. Pretty impressive. I want to show you these last things here. Oops. You guys know bay leaves, eucalyptus, right? Bay leaves and eucalyptus. Coffee, baking soda. You have baking soda. You know, these are all pesticides, right? They've all been used for cockroaches. Coffee. You didn't know this. Coffee is a nerve poison. Where's my anyone here in toxicology? No? Oh. I took a toxicology course when I was at Cal. So if you take an insect and give it pure caffeine, they die. Yeah, it's. So, but you'll never see these sold as pesticides because we eat them. We don't. So, but I'm just letting you know, the natural products, bay leaves, that's very repellent to cockroaches. You have many jungles and here and many natural products from plants. You might be able to find some natural products that we can use on cockroaches. Okay, now, you guys ready for a test? You got 4 images up here. Which one is not a cockroach? What do you think? Below? Which below? That? You sure? Okay, they're all scratching it. These are all cockroaches found from around the world. Cockroaches are like, you know the movie Transformers? The shapeshifters? Cockroaches can do that. They shapeshift. Some look like wasps, some look like beetles. These are all, even that's a cockroach. That's from Vietnam. Now, you're right, this is a termite. You're going to tell me termites are in the order Isoptera. But remember, the new DNA says all termites are social cockroaches. So if you read the literature carefully, when you write the scientific, today we'll talk about writing papers in science later, but you're supposed to put the order name. So for 30 years of my career, I put Isoptera for my termites. And for those of you who don't know Latin, Isoptera means same wing. They have 4 wings, but they look the same. DNA says no, they're cockroaches. So we had to change the order to Blattaria. They're just social cockroaches. Wow. Okay, let's go on to another one. Wasps. Wasps, you have many wasps. In fact, I almost got stung by one yesterday, running around in the oil palms. You have wasps, you have honeybees, you have ants. They're all in the same big order called Hymenoptera. And I know I'm using Latin again. I'm glad. Yeah, she's gonna. Now you gotta. When you do your lectures now, you got to use that book. Yeah, I know. Hymenoptera means membranous wing. And let me explain that. If you look at the wings of a bee or a wasp, it looks like cellophane. You can see through it. Membranous. That's where that. And Linnaeus knew that. When Linnaeus named all of the insects 250 years ago, he didn't have DNA. He didn't have fancy microscopes. He had a hand lens. So he named the orders after what he could see with a hand lens. And what's the most obvious thing you see on any insect are the wings. So I'll give you a fun one. You have grasshoppers here, right? You know what grasshoppers are? They hop around and they eat plants. Their wings go straight back, right? Their order name is Orthoptera. Ortho means straight. The optera is Latin for wing. So all that means is straight wing. You have many, many flies here. The cameraman's mad at me because I'm walking around here, sorry. Flies, you have many flies. You know what the flies are? They bzzz. How many wings do flies have? No? 2. 2 wings. Mosquitoes only have 2. You got to get some entomologists here. I have to work on that. So the Latin order name for Diptera, it's Diptera. You know what that means? 2 wings. Oh, interesting. So you guys have fleas? You know the fleas that bite dogs and cats? You know what a flea is? They have no wings, and they bite. They're very small. Then they're in the order Siphonaptera. And what that means is they have a siphon to bite you. And Aptera, aptera means no wings. See that? That's why this book is so good, because it explains. And that's why it'll help you to remember. All right. So wasps, bees, and ants are all in the same big order. And you have hundreds of thousands of them here in this part of the world. So how do you tell bees from wasps? Bees, wasps, and ants. How do you tell them apart? You actually look at the waist. What, right? In the case of the wasps, they have the big, thick waist. They're kind of chubby, beer belly. And ants are very skinny. They have a narrow petiole. And ants are like camels. How many different types of camels are there out there? 1 and 2 hump camels, right? 2 humps. 1 and 2 humps, right? Ants are the same way. They have 1 and 2 hump. Same way. They're just smaller. And then the antennae, in the case of particularly the wasp, it's straight. And then ants, elbow, bent. Got it? Okay. That's the quick way. Now, if you want to go through using keys or do a DNA test, it'll take days and cost you $100. That's different. But the quick way. I'm a field biologist, so you saw me yesterday. I'm quick. Because I put my hand in there. If they bite me, it's Coptotermes. I know these things. And I'll share them with you. I have many shortcuts. Okay. Indonesia also has many, many ants. In fact, you probably have a lot more ants. Some of you probably recognize. Do you recognize these ants? Wow. Yeah, hold up. I want to make sure I get the name right on these guys. I was looking for them yesterday, but I couldn't see them. There's one that's very, it has a fancy name in Indonesian. Hold up. Oh, there it is. No? No, not yet. Where is it? Almost. That one? No. Okay. The armed, these are from Indonesia. I looked up. iNaturalist. But I don't know which island. You guys have 17,000 islands. This is the spiny, this is the spiny armed ant. That's a good name. See all those spines? They'll stick you. The other one is the, of course, trapjaw. This is a famous ant. They say, have you guys seen this ant? It's in the jungle. They call trapjaw. So very fast, they catch, boom, very fast. And people in North America and Europe study how fast this is one of the fastest movements of any animal. And it's for something that's very, very tiny. And then, of course, you have this last one. What was this last one? They call it the hidden people ant. Here. Here's an Indonesian word for you. Starts with a B. You've ever heard of this word? No? Bunaponi? Has anyone heard of that? It's a rare ant in Indonesia. It's called the hidden people ant because they hide out there with the people. But these are just 3 of many, many more. These aren't going to be a pest problem. These guys will be weaver ants. You've seen the weaver ants that get in the trees and tie your leaves together. Then you have pharaoh ants, right here. You have ghost ants. They call this a ghost ant because there's a lot of white. You have Asian needle ant. And my favorite is the fire ant, Solenopsis. I know you have a bunch of those. These are the ones that pose pest problems around the world, and they're imported through international shipping trade. Very important. Okay. So why do ants come inside? If they're outside, why do they come inside? Our food, right? We have food inside our homes. When the weather gets bad, like monsoon season, you probably have a monsoon. Everywhere gets flooded. The ants come in, the spiders come in, the snakes come in, maybe the crocs. We have, in Florida now, we have boa constrictors. The big pythons are a big problem in Florida now. They were introduced. So sometimes big animals come in. The other thing is scale and aphids. The plants, the tiny insects, the green insects that feed on your plants, they produce honeydew that's sweet, and the ants attack, and they protect the trees. So in California, our #1 ant pest it's called the Argentine ant, Lepiphymi humuli. It's from South America. Actually, they call it the Argentine ant, but it's from Brazil, but that's another story. It comes into our homes. It's a tropical ant. It gets cold. They come in our homes. They also are a problem in agriculture. Our lettuce and our beans, our citrus. So we try to use biocontrol with wasps to control those, but the ants disrupt that system. So the Argentine ant is the #1 urban and #1 ag pest in California. Very unusual to do that. What do you do for ants? It used to be people would spray the outside of the building, but that's not good for the environment, is it? Because when you spray outside, that can get, like here it rains a lot. That'll get in the water table, that's bad. So we want to use baits, and there are many, many ant baits. And maybe we can find better ones here in Indonesia. The thing about baiting for ants is ants are picky. Sometimes they like sugar, sometimes they like meat. So when you want to bait your ants, it has to have both. Start your ant baiting outside early in the year. If you wait till the monsoon, it's too late. They're already in there driving you crazy. Got it? Okay. We're almost done here. How am I doing for time? Oh, good. You recognize this? Well, you do, but you don't count. Okay, termites. We have to talk a little bit about termites. Linnaeus, this is what he looked like. He's Swedish, so he's, a white guy, curly hair. He was royalty. In the olden days, entomologists were like, maybe not kings and queens, but they were dukes and earls. They were rich and famous. Nowadays, we're not so rich or famous, but they were very famous. And he was the one who named all the insects. Here's Systema Naturae was the first book. If you have this book in your garage, you're rich, because it's hard to find. So you might wonder, those of you who know termites have different castes. They have workers, they have soldiers, they have kings and queens. Those all look very different. So Linnaeus, when he first named termites, he was a little confused. So he thought the workers were some type of louse, and then the swarmers, he called them neuroptera things, and then he thought the earwigs were the soldiers. He didn't know, because that was the first time he saw termites, and they all came from Africa, so he didn't know. So what happened was this Frenchman, Gaspard Brulé. He was the one that named termites to be Isoptera. And the reason why he figured out, they have workers, soldiers, kings and queens. He looked at the wings, they were straight, Isoptera. He did that in the 1800s. So he was the first one to do it. Now, I put this here. Do you guys recognize that instrument? You ever heard of a didgeridoo? Okay. This is an indigenous person from Australia, Aborigines. You've heard of that term. And at one time, the Aborigines passed through here on the way to Australia. Their famous musical instrument is called a didgeridoo. Do you know how they make those? They take a piece of wood, stick it in the ground, the termites eat it out, and then they play it. So the Aborigines knew about termites 50,000 years ago. It's just they had their local names. It was the Europeans that changed the way we name things. And I say that because when you're out naming of all the insects on your 17,000 islands here in Indonesia, be mindful and respectful of the indigenous people, because they may also have a name. You have to be mindful and respectful of that. Okay, now, I think I told you this is a busy one, but I'll work through this fast. I already mentioned termites, and this was 2018. This is recent. Termites became cockroaches because of a DNA test. And to give you an idea what that DNA test was like, I know you can't read them. All this stuff up here are considered advanced cockroaches. All these names here, down here, are primitive cockroaches. And that arrow is where all the termite diversity fell, right smack dab in the middle. So termites and cockroaches are related and have been for millions and millions of years. For those of you who don't understand the DNA, let me give you a little morphology to help you with it. Cockroaches have 4 wings, and they have an anal lobe. Termite wings also have, they also have an anal lobe. See that? So that's this one here. That's a cockroach wing. That's a termite wing. Look kind of similar. This termite here is called Mastotermes darwinensis, and it's named after Darwin. It occurs in Australia and Papua New Guinea. It's considered the most ancient of all termites in the world. It's also an unusual termite because the females produce an egg case. So this here, the German cockroach, see that egg case? Mastotermes also makes an egg case, very similar. So wings, egg cases are similar. Linnaeus and them sort of knew there was something funny about termites and cockroaches. I'll give you one more little bit here. This is called the giant burrowing cockroach in Australia. It's big. This termite cockroach lives underground, and it has live young and trophylactic feedings. So the mother feeds the babies, and they feed on wood prod, and this is a cockroach. So it's easy to see the evolution from cockroaches to termites. That's just another arrow in there. It's too hard to see. All right. A little bit on Indonesia. You have many, many, many different types of termites here. Probably the most destructive is this one here, Coptotermes. You have different species. Coptotermes are easy to tell. They bite. You know, we saw this yesterday, didn't we? They were biting in our hands. That's just what they do. You also have, and they live in the soil. And you also have mound termites. You have macrotermes here. It's a big one. They bite even harder. Oh, my God. And then you also have this unusual termite called the drywood termite. They make the pellets, and I haven't seen any yet, but I know I think you have cryptotermes here. They're here. And you have a world expert on drywood termites right here. She's world expert right there. So she's checking my work. Just a little bit more on the difference. See that? This is, I think, Chow Yang's hand. Coptotermes can get very aggressive. Yeah, they bite. You have many, many, many termites here. So you're blessed. So far, I don't think the termite problems are big yet, but if you start looking, you will find more. And as you keep building, particularly if you use wood, and they like hardwood too, by the way. Hardwood, softwood, they eat it all. They don't care. I won't do that. You might wonder, this is the damage. The two big groups, subterranean termites and drywood termites. Subterranean termites are in the soil. When they come out to attack wood, they leave soil in the wood. The drywood termites, there's no soil. There's just pellets. So even though there's no termites in there, you can tell what group of termite did it. Just to give an idea. This is a shot from, I think this is from Thailand. Coptotermes again, make these huge mud tubes. And this is from California, our drywood. We have many, many drywood termite problems in California. Well, so what happens for subterranean termites, since they're in the ground, people used to put nasty chemicals in the ground, trying to kill them that way. A more advanced way is to use a bait. Remember, termites forage out for food, for wood. So if you can make the right bait, and here in Indonesia, you can make a very special bait. I think what we saw yesterday, you could bait it out. And the other thing about, you have ongoing bait research. Okay, for the drywood termites, they're harder to find. We need better detection equipment. In California, we fumigate. You don't fumigate for termites here in Indonesia, I doubt it. You do? You have Termitrac. Oh, you have that one? Oh, yeah. So drywood termites can be anywhere in a building, as long as there's wood. They're hard to find. If you can find them, then you can do a local treat with a pesticide or a natural product. And that's going to be part of your research, I imagine. Hemi's done it. Who else has done it? Maybe, is Brahm? No, Brahm didn't work on drywood. He worked on subs, I thought. We can't forget the good things termites do. This is me and Mike Haverty. We're in Australia, and there's Lisa, and there's Mike and his lovely wife, Marcia. The termite mounds are very big, probably bigger than what you have here. They have big termite mounds. So what's in these mounds? Grass. They cut it up and put grass in there. So they're like lawnmowers. You know how you have people cut the grass here? In Africa and Australia, probably here too, they cut the grass and put it in there, and they eat fungus. So they're farmers. So that's good. They do many good things. The last insect I'll mention are bed bugs. Yeah, here we go. That's another yuck one. People don't like this one. Linnaeus named them Cymicidae. And actually that translates into a cow. They didn't have beds back then. What's the French word for it? For those, chaise. Yeah, the French word. So she named them more after the French meaning for bed bugs. But they are blood feeders. So males, females, babies, they all feed on blood. Why do they feed on blood? Because we have a lot of it. We have maybe, 4 pints of blood? And before they sucked on humans, there are other bed bugs, dogs, cats, chickens, bats, birds. They feed on many, many, many animals. Yeah, the bites. I've been bitten by bed bugs on many. I used to feed them, You know, when you have them in colony, I used to do bed bug research, so about once a month, I'd put my arm out there and suck my blood. Ooh, itchy, itchy. Yeah, it's itchy. Oh, I want to come back to that. See that? So, male, female, all the babies. See how small they are? Very hard to see. Transparent, too. And they feed on blood. Now we're lucky that they don't transmit diseases like, if too many mosquitoes dead on you, you get sick. Bed bugs, no diseases yet. But those of you who are biologists knows that evolution happens every day, doesn't it? You have to be mindful of that. All right. There are over 100 species of bed bugs around the world. The most important ones, let me come back a little bit here. That's the human bed bug. That's the one in Asia. Hemipterus, you have that one here. And this is the one in Africa. So of those 100, there are 3. That's not bad. That poses a problem for humans. Now let me tell you the problem. This is Simus lectularis and Simus hemipterus. You have the one on my left. We have the one on the right. But we're both on the Pacific Rim. We travel a lot. A lot of people are worried that we're going to have both these all around the world. And it gets worse. They may produce a hybrid. Do you know what a hybrid is? You know, you have mom and dad, and then they, it's. So people are looking to see if they make hybrids. It's happened with our termites in Florida and Taiwan. We have Coptotermes formosanus, Coptotermes gastroi, and they form a hybrid. So this could happen with this one. Very dangerous. So we have to. All right, now, it used to be people thought bad things. If you had bed bugs, they said you were a bad person or from a bad part of the world. Normally they blame the Middle East for the source of bed bugs. That's not true. They did the DNA. So humans are about 2 million years old. Bats are 40 million years old. Because it used to be people thought we got bed bugs when we were living in caves in the Middle East and North Africa. But the DNA says the bed bugs are 100 million years old. So they probably fed in the nests of dinosaurs. So they just shifted. Remember the asteroid? Boom. No more dinosaur. Well, we got birds and humans, so let's move that way. That's probably what happened. I love science. Okay. You guys, do you watch the Paris Olympics? Okay, so they had a bed bug problem there. You're probably aware of that. You have some very famous scientists from this. Chow Yang Li was in Malaysia. He's in California now. He wrote a new book. The bed bug problems in Asia are going up. Uh-oh. Why? You got a lot of people in your cities. I mean, I thought, what's Tokyo? 36 million? 34 million. That's a lot of people. People move their stuff, right? It's just not people moving, it's their stuff. The problem is their stuff. Boxes and clothes and plants and whatever. And then on top of that, pesticide resistance. So it used to be people sprayed a lot for bed bugs. It was mostly the military. I hate to pick on U.S. military, but they were around the world. They were trying to protect their troops from malaria. The mosquito netting, right? And you spray that? Okay. So that also led to a lot of resistance development in bed bugs. That's a consequence. Okay. Yeah, more. I'm going to go through this because this is just. How do you look for bed bugs? Humans look, inspectors. But humans aren't so good because you got a bunch of stuff. They try dogs. Dogs are a little better. Sometimes they use carbon dioxide to attract them. Or we have fancy monitors. Bed bugs, you have to wonder, bed bugs have to find themselves. So they have a lot of pheromones that are aldehydes. You know what aldehyde, where are my chemists? You guys know aldehydes get airborne. You can smell it. These are the new technology trying to be tried around the world to reduce the bed bug problems without using too much pesticide. I used to work a lot with bed bugs. This is the Villa termiti. The researchers have known, maybe someday I can show you to you. This was built to test, it was originally built to test for termites, but we've tested for termites, ants, bed bugs, beetles, cockroaches. It's about the size of a 2-bedroom home with a bathroom. It doesn't have a bathroom. It has a sub-area, drywall, attic. And we were able to test many, many things in here, including bed bugs. Yeah, we put little bitty bags in here, and we put thousands of bed bugs in. This was a very dangerous building to go into, trust me. But that's what we do science for. We have to test. The main thing for bed bugs, they're hard to find. People don't like their beds sprayed, so they're looking at heat. Oop. Yeah, but the problem with heat is people's stuff. You can't get it hot enough. So the bed bugs escape. So there's always, and they're still looking. Maybe that's the next thing. When you're done with termites, find something to kill these guys too. You make a lot of money. This is a very famous book. One last thing, then I'm done. One more test. What's this? Tissue. Okay. We all know the obvious thing you do with it. Now, you guys are college students. You're going to be the next scientist. Can you think of a clever way of using these? Other than putting makeup on or go in the bathroom or can you think of another way of using this?
Kira-kira itu bisa dipakai buat apa aja?
Yeah. Ask them.
Tisu.
What do they think?
Entah buat bom atau buat apa
What
gitu.
they say?
Kan kalian next scientist nih. Apa? Student idenya aja, ide anehnya juga nggak apa-apa. Tisu bisa dibuat jadi apa lagi?
Yeah, this is a research question. So I give you a hint. What's this made out of? Trees. Wood, and wood is cellulose. What eats cellulose? We just talked about them. You got a whole bunch of them here in Indonesia. Where's my clicker thing? Termite, right? Remember? So, what happened in 1972? Mike Haverty again, Jeff LaFage, and Bill Nutting, they wanted to determine the diversity and foraging of termites in Arizona. This was, over 50 years ago. How do you do it? Can you look? You don't see them. So it was Jeff LaFage in his garage. He had some toilet paper rolls sitting on the floor. The termites ate it, and then he thought, oh, I can use these as a bait. So it's hard to see it. They put out thousands of these baits in the desert. You haven't been to Tucson. Desert. To determine the species of termites. There's termites in deserts. Yeah, you might go, I don't see them. They come out at night because it's too hot in the desert. They had a problem using toilet paper rolls in the desert. Can you think of a problem? Let's ask them. Problem.
Using the paper.
Yeah, what happened? What's the problem with using this in the desert?
Apa masalahnya kalau kita pakai tisu ini di padang pasir gitu?
It doesn't rain in the desert. Don't worry about that. What else? Other problem. There was a problem.
Masalah yang lain kira-kira kenapa
Actually,
nggak
there's two
dipakai?
problems. They're on the ground, and the termites would eat. What else might be down in here? Oh, how about snakes and scorpions and spiders? Woo-hoo-hoo. That wasn't the biggest problem, though. You know what the biggest problem was? Huh? They went. Ask them the biggest problem. It wasn't snakes, it wasn't spiders. Bigger problem. No rain.
Apa?
Any guesses?
Bisa nebak nggak? Nebak aja.
I'll tell you. Theft. People would drive around in there and steal these. Only in America do they do crazy. But I give that to you as an example. Many of you, well, some of you will become researchers. And I know you're thinking, ooh, I want to solve the world's problems, and that's great.
Yeah.
But sometimes you have to think simple.
Simple.
Simple. Get it? Okay. I think I'm done.
Okay.
Yeah, I'm done. I want to thank you, Lee, and the university and the dean. I'll take questions. Questions? And I have
You-
my interpreters.
Okay. Do you have any question before he
Oh, here
asks
they
you a
come.
question? Ada yang mau tanya sebelum ditanya?
Here they come.
Okay, good.
Here they come.
Yeah.
Of course.
Sure.
You got a microphone? Let's make this interactive.
Please mention your name and
Hello everyone, my name is Claudia Advensa and I'm from FMIPA. You guys call me Fensa. So my question is, doctor, the thing I want to ask may be a bit off from the material. However, during your research on insects and the other pets, what insects do you think surprised you the most? Which made you research them? Because I am also very interested in insects, especially in moth species. Because I once found a moth species that I thought was very beautiful and that made me want to learn about them. As far as I remember, the Latin name is Dyspania percota.
Wow.
okay.
Uh,
Can you get a question, bro?
help me. Yeah, what was that?
So she asked about what the insect that must surprise you most.
I think the insect, okay, the question is what insect surprised me the most? Bed bugs. I don't understand why they don't have disease. Right? Think about it.
Okay.
Yeah, they make you itch, but no one know. If you can figure that out, you could be very famous and very rich. Oh, I'll give you another one. I'll give you one more for termites. I think termites have a language, but it's acoustical. I think they have a language. So, you know, humans have language, right? You probably heard honeybees, the dance language of the bees. Have you heard of that? Maybe you heard about whales and chimpanzees. I think termites have a acoustical language. It just taps, like Morse code. Those are two important ones to work on. Those are PhD level topics. You can do it. You're welcome. Nice questions.
Nice question. Anyone else?
More. Here they
Okay,
come.
sure.
Could be a while.
Please state your name and where are you coming from?
Okay. Hello everyone, my name is Gofar. I'm from a biology department. I have a question for you, Professor Luis. The question is, as we know, some bug can be transmit some disease or pathogen and virus or something. My question is, can every insect use for termites for disease, virus, or pathogen? I believe maybe in somewhere in the world, maybe some researchers make some make it a test for spread the disease or virus using insect. That's all for my question. Thank you.
All right. I think I get this.
You get the question?
So you asked about creating a disease in termites.
Yep.
Right? Okay. A lot of people have tried that. And in fact, there's a big review article that just appeared in the Journal of Economic. It hasn't worked yet, and I'll tell you why. Termites live in the soil. The ones that live in the soil, it's very wet. And there are a lot of microbes in there. So they have a natural defense system. So a lot of people don't know this. Termites have a defense mechanism against microbes. So for us to create a pathogen, it might take them a while, but they've seen it before. I'll give you another example. Cockroaches are hard to kill around the world. Why? They evolved in the tropics into flora, where the leaves and dead animals and poop or whatever. So they had to have 300 million years of a resistance mechanism already in their DNA. So when we come with a pesticide, they're going to go, oh, I've seen that before. See that? So I don't know if that's called biological control. It hasn't been successful yet for termites, but people keep trying. They're trying it for cockroaches, they're trying it for bed bugs, they just keep trying.
Yes, sir.
Other questions?
So,
Do
Another
you think they
question?
understood this? Is it
yeah,
okay?
yeah. You answer the question.
Huh.
You answer the question. I guess.
Yeah.
Yang semua. Ada pertanyaan lain lagi sebelum Prof. Luisnya memberi question atau kita tutup?
We can talk about forest insects too, if you want. You want to hear more about forest insects?
Jadi nggak hanya tentang urban insect, urban entomology, tapi juga forest entomology. Kalau punya pertanyaan silakan.
Yes. Yeah.
So regarding the land conversion in Pontianak, we have some difficulties problem regarding to termites. In some of our housing facing problem with termite attack. So most of the housing in Pontianak are built on pit land.
Pit land.
So the main problem is the land conversion make the termite attack our housing. And we have conducted so many research about termites, how to how to protect our woods, how to protect our house. But unfortunately, in my opinions, we still not success because some of the companies still using not the biological preservation method, but still using the chemical. But for general people, they cannot afford that because it's too expensive. So some company try to change wood to use metals. But I think in Pontianak, using metal is not suitable because we are in tropical, so it become more heat.
And it'll rust.
So, yes. So in our indigenous people, they have knowledge how to prevent the termite attack by maybe build some foundation with some concrete or build our houses maybe a couple meters from above. But in Pontianak, it's quite difficult because the land is expensive, the materials is expensive. So what is your suggestion for our problem?
Okay,
Thank you.
wow, that's an involved question too, but I think I get it. And I've seen many termite problems around the world. It's not a good idea to put wood on the ground, not good. With Chile, Africa, here, the fungus and the termites, it's gone within a year, maybe months, gone. So you need to put a barrier between the structure and the house. I'll pick on Pakistan. They don't use concrete, they use gravel. You know, gravel is crushed rock. Gravel, not so good because the termites whistle through it and then they get the floor. A concrete foundation is good, or raise up, I like. That's better. That's the first thing. The next thing you're going to have to do is, you're in the tropics, you have many, many, many insects and many, many, many microbial things to attack. I like to have a buffer zone around the house. No wood piles, no extra planting bed that touch the house. It's so you can see. If you fruit trees too, you know, if you're going to have fruit trees, I know we have, you know, maybe 5-10 meters from the house. Space is good. Space is good around the world. That works around the world. Now, let me tell you what's going to happen globally. Big picture view. There's a problem with using concrete. Concrete makes too much carbon dioxide. It's mostly China and India. They're the biggest producers. So the UN is trying to talk them not to use so much concrete. What are you going to use? Wood. So if you use wood, you got to do something to protect it. There's no many things you can do. You can use special hardwoods that are resistant, but then that means you have no hardwood forests. They cut them all out. You can use wood preservatives, and that the results are mixed. The problem with wood preservatives is they're also toxic. And then when you remodel your home, where do you put all that wood? So maybe the best way is to use, protect our wood from moisture, at least the rain. I know you have high humidity. And then have a buffer zone where you can, and you have to look. The problem in America, people don't look at their houses. We have many foundation types. We have slab, but slab doesn't help in the mountains. That's called a raised perimeter. That's where the termites attack in much of North America. People don't look. That's where they hire us for, to look. And but you can do things. Physical barriers, sand barriers, physical barriers. There's these special termite guards. You can bait. In North America, I think we're going to do more preventive baiting. That's what I want to see happen to the oil palms. Just, okay, we got a problem, bait them out. Next one, bait them out. I think we're going to try and do that for our homes in North America, hopefully before I die. We need something to see through walls. Humans can't see through walls. Termites can't. Well, they get there. The last thing is, when wood is attacked, when do you have to take the wood out? We don't have a device for that. If this looks good here, but behind the wood could be all gone. I can't tell. Whoa. In North America, the way they do it, when the wood is 10% or more damaged, take it out. That's very expensive. What's 10%? Based on what? So that's where I talk to engineers. We need a device. Maybe your engineers can help. It might be X-ray. You know, you worked in Kyoto.
Okay.
Microwave we try, but it's too small. We need big. Other questions?
Other question?
Oh, materials? What'll happen is you're going to use more wood because of global warming. Because the international treaties say we got to get the carbon dioxide down. Concrete, it produces too much carbon dioxide. So what's left? Wood. But wood brings a different type of problem. See, so that's why I'm here, because
Yeah, that's why you are
you're
here.
going to use more and more wood, not just
That's
for
why we
pulp,
invite you.
but for building. They're talking about they're building buildings in Europe right now, 30 stories out of wood, 30 stories. They're building one in Oakland, in my state, 20 stories, wood, all wood. That's huge. So, and termites attack wood. What do? It's over 100 feet tall. I don't have a good answer.
Okay, thank you very much, Prof. Luis. It is very insightful talk, and but unfortunately our time is over. So it's almost 7, something like that. Yeah. Okay. Please give big applause for Prof. Luis. We got a lot of insightful information from him, and thank you very much for sharing the great information to us. But yeah, our time is over. So thanks for the all our audience for the question and feedback. Thank you very much. Ibu mau okay, I think give it to the master ceremony.
Check, check. Very insightful and very interesting. Please give a last big applause for our seminar today. Ladies and gentlemen, we are about to come to the end of the session. To express our gratitude, we bring the certificate also souvenir for our speaker. For the session mentioned, please Dr. Insinyur Farah Diba, Esut MSI IPU, to give the certificate and souvenir. Please stand up in the front of stage. Well, ladies and gentlemen, seminar Ramin series 31 about urban entomology has ended. I apologize for any inconvenience, and that's might have a reason in all of the session. So before we head out, I would like to thank to everyone who saw up today and stay still eagerly until the end of the session. We are looking forward to see you again in the next sitting agenda. Good evening and wassalamualaikum warahmatullahi wabarakatuh.